All right, guys, so let's add some more identities to our arsenal. Sum and difference. So we've got two types, sum of angles, difference of angles, sine, cosine, tangent for both. So again, I'm going to let you use these on your tests and everything. We're going to do two things with these. We're going to prove identities with them, and we're also going to use them to find exact values of angles. So you might remember seeing this guy, the unit circle. I'm going to give you a copy of this also. Thing is, it's asking us to find sine of 165. Okay, you can take your calculator and type that in. Most calculators you can't, but this one you can. It'll give you your exact value. Most calculators would spit that out. However, I'm not interested in if you can just type that in the calculator or not. So what I want you to do is figure out how to combine these angles with a sum or difference to get 165. So let's see. Here's our options. We're adding or subtracting. So I can say 180 minus something. Well, that's not going to work because we don't have a 15 in here. We got 30, 45. That 45 we're probably going to use since it has a 5 in it. Let's see if we can add, let's see, 165. So that's 120 plus 45. So there we go. We're going to use these two angles here. If you remember, these order pairs are cosine, sine. So for this one, sine of 165, we're going to say that's sine of 45 plus 120. So let's go get our identity. First one right here. Okay, so we know that's sine of A times cosine of B plus cosine of A times sine of B. So we're going to use that. So A, in our case, is 45 degrees, and B is going to be the 120 degrees. So for sine of 45 plus 120, we're going to use sine of 45. Let me just get some more space to work with. So we're going to do sine of 45 times cosine of 120 plus cosine of 45 times sine of 120. That comes from right here, sine of A, cosine of B, plus cosine of A, sine of B. So now all we need to do is use that unit circle and find out what value each of these are. So you're going to have this next to you, so you can just look it up. I think I have one in here somewhere. Yeah, right there. So sine of 45, I know that is square root of 2 over 2. Times cosine of 120. Here's 120, cosine's negative a half. Plus cosine of 45, again, that's square root of 2 over 2. Sine of 120, well, that's positive square root of 3 over 2. So now you're going to manipulate this, just, like any old fraction. That's negative square root of 2 over 4. When we multiply numerator, numerator, denominator, denominator. Plus, we multiply square roots and multiply the inside parts. So 2 times 3 is 6. So that's square root of 6 over 4. We have the same denominator, so we can combine those together and get negative square root of 2 plus square root of 6 over 4. And again, if we use our calculator, it's the same thing. It just uses the commutative property to switch those two around. All right, so that's what I'm going to need you to do. Calculator, not so much. I need you to use that unit circle. So let me grab the next one. All right, now we got cosine of negative 75. Okay, let's figure that one out. Again, we're trying to figure out what two angles either add up or subtract to give us a negative 75. So here's our options. Since we've got a negative there, I'm pretty sure we're going to be subtracting. So let's see, trying to get negative 75. It's got a 5 in it, so we're probably going to use that 45. Maybe that 135, I don't know. Let's try that 135. Minus 60 maybe? There we go. So 135 minus 60 is 75. We need negative 75. So we gotta go the other way around. 60 minus 135. There we go. So we're gonna rewrite this as cosine of 60 minus 135. So then we're gonna go grab our identity. We're doing a difference with cosines. This is what we need right here. Something real quick. Now I can easily grab them. Okay. So let's plop that down on here and see what we got. So A, in our case, is going to be the 60 degrees. And B is going to be 135. We don't need negative 135. That minus sign's taking care of that for us. So it's 60 and 135. So that's going to be cosine of 60 times cosine of 135 plus sine of 60 times sine of 135. So then we grab our unit circle and look up these values. So for 60, cosine is a half. 135, cosine's negative square root of 2 over 2. Sine of 60, that's square root of 3 over 2. And sine of 135 is going to be a positive square root of 2 over 2. Again, just multiply these fractions together and combine them with the common denominator. Negative square root of 2 over 4 plus square root of 6 over 4. And we have negative square root of 2 plus square root of 6 over 4. And you can check yourself. Cosine of negative 75. Same thing. Again, commutative property switches those around, but this is perfectly fine for me. Now, if we look at the next one, we're dealing with some radians here. Remember, our angles can be measured in degrees or in radians. For you, the unit circle has both. When it's in radians, though, it does make it a little trickier to figure out what we're adding and subtracting. I'll give you a hint. You'll think about everything as pi over 12s and simplify. That makes it a lot easier. So we're looking for just a pi over 12. Well, I've got pi over 4 and pi over 3. So that's like a third and a fourth. So pi over 3, that's 4 pi 12. Pi over 4, that's 3 pi over 12. So if you think about those in terms of pi over 12s, you can easily see that if we subtract them, that's what's going to happen, pi over 12. So this one's going to be tangent of 4 pi over 12, which is pi over 3, so I'll write it simplified, minus pi over 4. And if you're good about thinking with fractions, you can just ignore the pi's, try and make 1/12 from thirds and fourths and sixths. Okay, so that's what we got here. We got pi over 3, pi over 4. We're dealing with tangent, So we're subtracting, it's this one down here. Grab that. Okay, so tangent of A minus tangent of B. So this is going to be our A. That's going to be our B. Again, don't worry about the negative sign. So that's tangent pi over 3. I do want you to write it out in the formula before you actually start plugging in the values. Minus tangent of pi over 4 over 1 plus tangent of pi over 3 times tangent of pi over 4. So now let's look up these values on our unit circle and see what we got going on. Tangent of pi over 3. So pi over 3 is right here. Tangent, oh no, that's not on here. But if you remember, tangent from our quotient identities is sine over cosine. So to get that one, we just do square root of 3 over 2 divided by a half. Sine over cosine. And you'll use these enough that you'll eventually memorize them. I would suggest using the division symbol instead of a fraction inside of a fraction so you don't accidentally push the square in the wrong spot. And you get square root of 3. So that right here, tangent of pi over 3 is square root of 3. Tangent of pi over 4. Well, it's the same thing divided by itself, right? So that's just going to be 1. Square root of 2 over 2 divided by square root of 2 over 2. Oops. Get out of there first. Over 2 is 1. So now we know what tangent of pi over 3 is, and we know what tangent of pi over 4 is. Let's plug them in. So this doesn't do anything. Square root of 3 minus 1 over 1 plus square root of 3. From here, I'll let you just type in the calculator. We do need to rationalize our denominators. So once you get to this step, I will let you go ahead and plug that in. I'll show you how to do it by hand in a moment, though. And we get 2 minus square root of 3. So let's do that by hand real quick. See what's going on. So how did that happen? Well, if you remember, we have to rationalize our denominator. To do that, we multiply by the conjugate of the denominator to the numerator and denominator. Top and bottom, multiply by the bottom with a different sign in the middle. These are binomials. Treat them as such. I advise using parentheses. But again, for my class, I will let you take it from here, shove it in the calculator. But in case your future classes don't let you do that, let's do it by hand. So distributive property for the numerator. Square root of 3 minus square root of 3 times square root of 3 is 3. Negative 1 times 1 is negative 1. Negative 1 times negative square root of 3 is positive square root of 3. Over 1 times 1 is 1 minus square root of 3 plus square root of 3. That's a minus 3. Well, now combine our like terms in numerator. That's 2 square roots of 3's minus 4 Combine like terms with the denominator. -2. Oh, those cancel. So it's just -2. Let me write them down. All right, and then I'd advise splitting that up. 2 square root of 3 over -2 minus 4, or plus a -4. Let's do it that way. Over -2. That way you can see what happens better. So that's become negative square root of 3. Negative is positive. That's 2. And look what the calculator said. 2 minus square root of 3. Negative square root of 3 plus 2. Commutative property, same thing. 1 second. And we're back. So let's take a look at the next one. This time we have cosine of -19/12 pi. Let's see what we're going to do with that thing. So again, the hard part's just figuring out what fractions we combine to get -19/12 pi's. Let's look at our options. We have all these. Again, think about them in terms of twelfths. So this is 22 twelfths. This is 21 twelfths. So we're probably going to use something along these lines. 20 twelfths. We're looking for -19 twelfths. So let's see. The smallest I can get is 2 twelfths right here, 5 or 6. 5 or 6 is 2 twelfths. And then if we could find something that's 21 twelfths, which we did a moment ago, that's what we could use. So again, to get this in terms of twelfths, we multiply to the numerator and denominator by 3. That's going to be 21 twelfths right there. So 7 pi over 4 is 21 twelfths of pi. All right, so if we combine these, 2 minus 21 is -19. Check. Yeah, it is. So that's what we're going to use. That's going to be our A, that's going to be our B. We're subtracting with cosine. I knew it was going to be subtracting because we have a negative there. So that's a big giveaway that you got to use subtraction. That's going to be cosine, that's terrible, of 2 pi over 12. Should simplify it. Pi over 6 minus 7 pi over 4. This is our A. This is our B. Negative sign doesn't matter. So that's going to be, if we look at cosine's difference form, I think we already used that one, didn't we? Or we used the sum. We used the difference, so let's just grab it right here. Cosine of A times cosine of B plus sine of A times sine of B. So let's see what we got going on. Cosine of A times cosine of B plus sine of A times sine of B. I just need to look up those values on the unit circle. Cosine again is the first value, so pi over 6, that's square root of 3 over 2. Times 7 pi over 4, that's down here. My head's in the way. Square root of 2 over 2. Plus sine of pi over 6 is a half. Sine of 7 pi over 4 is negative square root of 2 over 2. Multiply 6 over 4, negative square root of 2 over 4. This is not a lot, square root of 6 minus square root of 2 over 4. That's it. we leave it like this because the denominator is an integer. It's not a irrational number. We don't leave square roots in the bottom. So we can leave integers in the denominator. All right, this is number 5. 7 pi over 12. Okay. Let's pause this. We might add, might subtract. We could probably play around with the numbers here. Let's see. That's going to give us what we need. So like I said, as you use these, you'll get more and more familiar with them. And you'll probably memorize them before too long. So same thing here, pi over 3, pi over 4. But this time instead of subtracting them, we're going to add them. And that will give us 7 pi over 12. So this is going to be rewritten as sine of pi over 3 plus pi over 4. Go ahead and identify my A and my B. That's sine of, picture that sum formula here. Add A plus B. So sine of pi over 3 times cosine of pi over 4 plus cosine of pi over 3 times sine of pi over 4. Okay, unit circle. For pi over 3, sine is square root of 3 over 2. Cosine of pi over 4 square root of 2 over 2. Cosine of pi over 3 is a half. Square root of 2 over 2. If you don't believe me. So pi over 3, sine square root of 3 over 2, cosine's a half. Pi over 4, they're both square root of 2 over 2. If we're dealing with the first quadrant, you probably already have those memorized by the time you're done with this lesson. Square root of 6 over 4 plus square root of 2 over 4. And combine those, square root of 6 plus square root of 2 over 4. No, you can't say that's square root of 8. It doesn't work like that. That's it. Next. So we got another negative, so we're definitely be subtracting something. 13 pi over 12. Let's see. That's 10. I don't think we're gonna make it 3, so let's try this one. That's 9. 9 and 4. Yeah, how about these two? So if I do 3 pi over 4, we're subtracting. We could do the negatives, but that would be way more confusing, so let's not do that. So I need something bigger than 13, so I have 22, 21. Right here we have 20. Over here we have 16. We need 13, so right here we have 15. All right, there we go, 15 minus 2. So I know pi over 6 is a 2, pi over 12, so let's try that. 5 pi over 4. And pi over 6. Let's see if that'll work. So common denominator of 12, that's 15 pi over 12. That's 2 pi over 12. And we need to go the other way around. We need 2 minus 15 to get that negative 13. There we go, that's what we're going to do. We're going to rewrite this. Tangent of pi over 6 minus 15 pi over 12. Simplify. So 15 pi over 12, we can write 5 pi over 4. All right. So the difference for a tangent, I think we just use that. All right. So tangent of A. So tangent of pi over 6 minus tangent of pi over 4. Again, we don't worry about that negative sign. That's why we're using our difference formula. 1 plus tangent of pi over 6 times tangent of 5 pi over 4. Again, to look up these values, we have to do sine over cosine. Sine over cosine. Let's use our calculator for that. The pi over 6, that's a half, divided by square root of 3 over 2. That is square root of 3 over 3. Square root of 3 over 3 minus, that's going to be negative 1. We look at 5 pi over 4. 5, wait, okay, so 5 pi over 4, that's going to be a positive 1. It's negative square root of 2 over negative square root of 2, so yeah, same thing divided by itself is 1. You can type it in if you want. Not gonna. So tangent of 5 pi over 4 is this divided by each other, 1. So let's plug it in the bottom. Simplify it a little bit. So after you do the multiplications, for my class, I'll let you just type this in the calculator. Future classes there, you're probably going to do the algebra by hand, so let's do that now. From here, from me, typing the calculator will be done. So we just have square root of 3 over 3 minus 1 plus square root of 3 over 3. And that's negative 2 plus square root of 3. All right. So to do this one, we're going to multiply the top and the bottom by the conjugate. You can do that first, or you can take care of that complex fraction first. Complex fraction first. We're going to get a common denominator on the top and the bottom. So square root of 3 over 3, and 1 is 3 over 3, so that's going to be minus 3 over the 3. Down here, same thing, 3 plus square root of 3 over the 3. We're dividing a fraction by a fraction, so we're going to flip and multiply by the reciprocal. Square root of 3 minus 3 over 3 times 3 over 3 plus square root of 3. Those cancel. Square root of 3 minus 3 over 3 plus square root of 3. At least we got rid of that fraction, so now we need to get rid of our radical in the denominator. Multiply by the conjugate. These are binomials, so might as well put them in parentheses when you're multiplying. That way you don't forget to distribute properly. So that's 3 square roots of 3 minus 3 minus 9 plus 3 square roots of 3. On the bottom, 9 minus 3 square roots of 3 plus 3 square roots of 3 minus 3. Let's see what that turns out to be. Among all like terms, I have 6 square roots of 3 minus 12 over 6, and those cancel. To simplify that, you can split it up if you need to. 6 square roots of 3 over 6 is square root of 3. Negative 12 over 6 is minus 2. And that's it. Negative 2 plus square root of 3, square root of 3 minus 2. Same thing. All right. Let's see what's next. All right, I'm going to save the identities for another video. This video is already getting pretty long. All right, we're in quadrant 1, so that tells us everybody's positive. And that tells us how to draw a triangle, because we're going to need to figure out, not for tangent, huh? Let's look at our tangent formula. Tangent of A plus B. For that one, all we need is the tangents, and we already have both of those, so that's easy enough. All right. So we don't know what our angles are, and we don't really care what our angles are. We know what the tangent of A is, and we know what the tangent of B is, so we can substitute those values in here. We don't need to do the inverse tangent to find out what that angle is or anything. We just plug it in. So for tangent of A, that is 7/24. Tangent of B, that is 15/8. Minus 7/24 times 15/8. Our radical's in here, so just go ahead and do the basic arithmetic. Add fractions, need a common denominator. That's a 24, that's an 8. Multiply that by 3. So it's going to be 45 plus 7 is 52 over 24. Plus the 7, 2. Yeah, I'll write that as a separate step so I don't confuse everybody. That's 7/24 plus 45/24. Got a common denominator. Equivalent fractions here. On this one, we're just going to multiply 1 minus 7 times 15. 105. Actually, let's do the whole thing in the calculator so it'll simplify it for us. That's 35/64. And of course, we know 1 is 64/64, so let's use that. 52/24 on top. 64/64 minus 35/64. Just keep going. Simplify that denominator a little bit first. 64 minus 35, that's 29. Fourths. Divide fractions, we invert and multiply. Simplify the denominator. We're just going to use the calculator here. (416/87). Sure, why not? So what does this represent? This represents tangent of whatever angle A is plus whatever angle B is. Don't know what they are, but if we add them together and take the tangent of that, we get 416/87. That's all we got to do here. Let's look at the next one though. So we got quadrant 1 again, so everybody's positive. Now this time we have sine of A and cosine of B, and we want sine of A plus B. So we look at our formula for sine. The sum of sine is involving sine of A and cosine of A, cosine of B, and sine of B. So we need to figure out what cosine of A is and what sine of B is, because we don't know those yet. So before we can add them up, we need to find out what these two values are. So quadrant 1, triangle looks like this. So for A, opposite is 5, hypotenuse is 13, that's a 12, 5, 12, 13 right triangle. Pythagorean theorem if you don't believe me. So triangle for B now. Cosine 4/5, 3, 4, 5. So again, if you don't believe me, theorem will work. So now we have our two triangles. We can get cosine of A is 12/13. Sine of B is going to be 3/5. So now we have sine of A, sine of B, cosine of A, cosine of B. We can find this formula. All right, so sine of A is 5/13 times cosine of B is 4/5 plus cosine of A is 12/13 times sine of B is 3/5. This one's easy enough. Those cancel. 4/13 plus nothing canceling here. 36. There's 75, right? Okay. And this is going to be 20 over 65, right? So, I didn't need to cancel that out. It helps if I didn't, actually. So that's 20 over 65. I'll just rewrite it. One time when canceling doesn't help you. I'll simplify to the end here things. And that's going to be 56 over 65. And those do not have anything in common. So that's our answer. Done. Now, if this was in a different quadrant, we'd have to take care of our negative signs. Let's see if the next one's in a different quadrant. No. Okay. Oh, yeah. Quadrant 2 right here. Cool. Oh, did I not pay attention? Yeah, okay. Good. So sine of A is in quadrant 1. Everything's positive. 12, 13 right triangle. Quadrant 2 is looking like this. That the x value is going to be negative, so that's going to be a negative 3. Pythagorean theorem, you'll get 3, and it has to be negative because we're in quadrant number 2. So we're looking for cosine of A minus B. Let's see what that looks like. So we got the sine of A and B, we need the cosine of A and B. So cosine A is 5/13. Cosine of B, negative 3/5. Now we can plug it in the formula. 5/13 times negative 3/5 plus 12/13 times 4/5. And again, we could cancel right here, but if we do that, we won't have common denominators. So let's just leave it alone. Do it like it says, negative 15 65ths plus 48 65ths. Add those together and you get 33 65ths. That's it for that one. So make sure you pay attention to what quadrant you're in. The quadrant will tell you who is positive and who is negative. So just remember, first quadrant, everybody's positive. Second quadrant, negative x, positive y, negative negative in the third quadrant, and positive negative in the fourth. Yeah, we're gonna do this one on the next video. Go ahead and chop this off right here. See you in a minute.